Amid intensifying military technology competition, China has once again sparked global concern with its latest ambitious move in the skies. Following the launch of the J-20 and the development of the J-35, a new name has emerged that is starting to generate widespread speculation. Among global defense analysts, the J-50, this sixth-generation fighter jet is not simply continuing a legacy but attempting to create a new paradigm for air dominance, posing a serious challenge to the West's long-standing dominance. One of the most striking aspects of the J-50 is its silhouette, which completely abandons conventional forms. Without a vertical tail and canards, the J-50's design looks like a hybrid between a fighter and a stealth bomber. This styling is reminiscent of the US B-2 Spirit bomber, but with a sleeker, more maneuverable body. This approach is more than just futuristic styling. The removal of the tail element significantly reduces radar visibility and creates cleaner aerodynamics. On paper, this makes the J-50 nearly invisible to enemy radar. Major advantage in modern air combat, which relies heavily on early detection. However, with major innovations, significant challenges also arise. Without traditional stabilizers, the J-50's flight stability relies entirely on an AI-driven fly-by-wire system. Algorithmic performance, not just physical design, is now the key determinant of the jet's success. Critics call this approach too reckless. They question whether China has enough experience and data to convince the world that the system is combat-ready. In the world of military technology, unwarranted boldness can lead to costly failures. However, behind the doubts lies speculation that the J-50 is more than just a test. Project But, rather the spearhead of a revolution in Chinese air doctrine. The jet is believed to integrate a unified combat network architecture, enabling real-time connectivity with combat drones, surveillance satellites, and ground-based command centers. In other words, the J-50 is designed to dominate the air, not just physically, but also digitally, creating a battlefield dominated by algorithms, not just speed or firepower. If true, the J-50 is not just a fighter jet, but a next-generation warfighting platform that could change the face of global air conflict. Another interesting feature lies in the J-50's air intake system, continuing the development of the DSI diverterless supersonic inlet from the J-20 era. The J-50 enhances it with an internal subrib structure, technology aimed at maintaining engine performance at high speeds and optimizing airflow efficiency. Furthermore, the J-50's wingtips are designed to be retractable and foldable as needed. In slow cruise mode, the wingtips are extended for maximum lift. When entering stealth or high-speed mode, they are retracted, reducing drag and radar profile. This move demonstrates that China is no longer simply copying foreign designs. It is now experimenting and creating original solutions, even potentially setting new trends in the future. However, behind this potential, an important question arises: has this all undergone adequate combat testing? The mechanical durability of the flexible wing and the performance of the DSI subrib under extreme stress are critical areas. In real-world combat conditions, a single structural failure could be catastrophic. Therefore, the success of this system depends on thorough testing and manufacturing readiness. Beyond aerodynamics and physical structure, the integration of advanced avionics systems into the J-50 is also a major gamble. The aircraft is rumored to feature next-generation sensor, fusion, and tactical AI capable of millisecond decision-making technology that is not yet fully mature, even in Western aircraft. If these systems are successfully implemented stably in various combat scenarios, the J-50 will not only be a symbol of China's ambitions, but also a real threat to global air dominance, which has so far been controlled by Western powers. However, if it fails, the entire J-50 project could become a reflection of the gap between technological ambitions and battlefield realities. Interestingly, the J-50 isn't the only sixth-generation jet under development in China. Chengdu Shenyang's traditional rival is developing the J-36, which takes a different approach, focusing on electronic warfare, area control, and integration with drone systems. These two parallel projects demonstrate the complexity of China's defense dynamics. Unlike the US, which clearly separated the F-22 and F-35 projects, China has allowed two designs to develop simultaneously without public clarity. Some analysts have called this a closed competition between domestic manufacturers. Whoever is more effective, efficient, and ready to deploy will be the winner. However, this approach can be a double-edged sword, draining budgets, slowing production, and creating strategic confusion. If China fails to make a decision quickly, it could fall behind in the global air race. Too many variants without a single central focus could backfire strategically in a real-world conflict scenario. Furthermore, the existence of these two projects also reflects a shift in Chinese military doctrine, which is increasingly oriented towards full-spectrum dominance from air power to electronics to artificial intelligence. Both the J-50 and J-36 appear to be designed not only to defeat enemy fighters conventionally, but also to serve as control centers in a future combat ecosystem, including integration with loyal wingman drones and cyber warfare systems. This suggests that Beijing is aiming for asymmetric superiority beyond traditional air combat, something that could shake the balance of power in the Indo-Pacific if implemented quickly and effectively. Beyond its design and control systems, the J-50's weaponry is a key factor in determining whether this jet is merely stealthy or a real threat on the battlefield. Leaks from military sources suggest that the J-50 will likely carry next-generation, AI-guided, long-range air-to-air missiles, with a range exceeding that of the PL-15A, top-of-the-line missile that has already caused unease in the West. Rumors have even circulated that miniaturized hypersonic missiles are being developed exclusively for this platform, creating a scenario where the J-50 could disable enemies before they even detect its presence. Furthermore, the J-50 is believed to be capable of carrying directed energy or laser weapons for defense against drones and incoming missiles, a significant leap from traditional dogfighting to disruptive technology-based warfare. If true, the J-50 is not only aiming for air dominance but also systemic supremacy across the entire spectrum of future technological warfare. However, all of these advantages raise a critical question. To what extent have these weapon systems undergone rigorous integration and field testing? How reliable are AI-guided missiles when facing electronic jamming or complex battlefield scenarios? Without concrete evidence of efficacy in extreme conditions, these weapons can still be considered mere paper weapons, fearful on paper, but fragile in reality. On the other hand, the focus on advanced weapons and full digitalization also creates a heavy reliance on networks, satellites, and command nodes. This means that a single cyberattack or system sabotage could cripple the J-50's superiority in an instant. In the era of asymmetric warfare, digital weaknesses can be more dangerous than physical ones. Therefore, the J-50's weapons development is not only about destructive power, but also about survivability in multi-domain warfare scenarios. Developing a cutting-edge aircraft like the J-50 is clearly no small investment. Radar-absorbent materials, artificial intelligence-based control systems, and experimental aerodynamic structures all carry significant costs. The project is estimated to cost billions of yuan, perhaps even surpassing the total investment in the J-20. This presents a major dilemma. Can China produce the J-50 in sufficient numbers to form a substantial fighter force, or will the jet simply be a prestige symbol, available in limited numbers and with little strategic impact? Unlike aircraft like the J-31 or JF-17, which are designed for the export market, the J-50 appears to be exclusive to the PLA. This means that potential revenue from overseas sales could be sidelined. Without international market support, the entire cost burden falls on the domestic budget, which is already facing its own economic pressures. Worse still, if the project were to fail, the damage would be not only financial but also reputational. The world could see the J-50 not as a major achievement but as an example of ambition that exceeded technological readiness. Furthermore, the J-50's presence could also trigger a strategic response from rival nations like the United States and its allies. If the J-50 truly succeeds in combining advanced stealth, artificial intelligence, and superior range, it would force Western nations to accelerate the development of next-generation air defense systems or even accelerate the adoption of new fighter platforms like the NG. In this scenario, the J-50 would not only be a test of China's military capabilities but also a catalyst for an escalation of the global arms race, a costly consequence that could lead to future regional instability. The J-50 is clearly no ordinary project. It symbolizes China's determination to challenge the status quo and establish itself as a global air power leader. Its design innovation, technological boldness, and aggressive development strategy demonstrate the significant strides they are making. However, with such significant strides, significant risks are always looming. Amidst the praise and skepticism, one question remains. Will the J-50 become a symbol of China's resurgence in the skies, or a bitter lesson in ambition that goes too far without a solid foundation?